All right, we're back. We're still on page 4 of note 6 of Calc C. We're just doing mixed review with the series convergence tests. And so let's see if we can do this. This one looks like a series that we dealt with before. So I'm going to try to compare it to the natural log of n over n, which we know diverges. And how did we know that that diverged? I guess we direct compared. So this diverges by direct comparison to 1 over n, because natural log of n is bigger than 1 when n is bigger than e. So eventually natural log of n over n is bigger than 1 over n. 1 over n diverges, so diverges by direct comparison. So I'm going to start with that premise. You could also use the integral test on that, like whatever. And so I'm now going to use the limit comparison test. So this is where, if you do enough of these and really pay attention while you're doing them, you start to build up kind of like a mental library of the various series that you could potentially use to make your limit comparisons, your direct comparisons, all of those. Like I happen to know that natural log of n over n diverges, so that was useful. Dominant terms. This times this is dominant, and then this times this is dominant. So really this is just 1/2, which is positive and is finite. And that means, since the natural log of n over n diverges, this other thing, which is the natural log of n over 2n, oh my god, that's supposed to be a 2, check that out. 2n minus 1 diverges by limit comparison test. All right, so not bad. This, nice. The limit as n approaches infinity of 2n over 3n plus 5 is 2/3, which is not 0. Therefore, this thing diverges. Nice. We could use a lot of these. 3n plus 5 diverges by nth term test. I was like, what test did I even use? Nth term test, which is only a test of divergence. God, there are so many. I'm going to compare this to 1 over n squared. So limit as n approaches infinity of, I'm just going to make it n to the 4th plus n squared. So I'm like multiplying it out as I go, which is positive and finite, mostly because I don't want to spend the rest of my life doing this page. Since 1 over n squared converges with p equals 2, the original thing, n squared over what? Oh, n squared plus 1 over n to the 4th converges by limit comparison. I will use limit comparison every chance I get. It's just like the most straightforward of them, I feel. Here, I'm going to use it again. I'm going to use it again, and I'm also going to kind of like cheat here. So I'm going to basically say the numerator is basically n squared. The denominator is basically n to the 5th. N squared over n to the 5th is 1 over n cubed. So we're going to compare that. Then I'm going to cheat on my limit also. These are all bad habits. 2n cubed n minus 1 squared over 3n to the 5th. Multiply everything out and then do dominant terms. You're going to just get 2/3 here, the ratio of the coefficients. Positive, finite. This is usually like when we do this in class, I'm like, who wants to go to the board and do 15 problems simultaneously so that we can get through this? But we don't have that option here. So since 1 over n cubed converges with p equal to 3, which is greater than 1, we know that this other thing. Also, you'll notice maybe that I'm not really writing the bounds on my summations. That, I think, is a common thing to do because you know what you're doing. You're doing infinite series. I guarantee you there are teachers out there who will flip out if you do that. So like your mileage may vary, but that's what I'm gonna do. So this was a limit comparison again, always and forever. All right, what are we gonna do here? All right, so I'm gonna do a little math on this before I like compare. Bring down this n as the coefficient properties of logs. So this is really the natural log of 2 over n squared, which is actually just the natural log of 2 times 1 over n squared, which, so this just converges because it is a p-series. And we don't have to do anything. Nice. That was just a hidden p-series. Perhaps the next one is also that. It's definitely not. So I am going to do the same thing though, like the same exact thing. So I'm going to make this the natural log of 3 over n factorial is the quantity n minus 1 factorial. Okay, so what is n? My sense is this has to converge because n minus 1 factorial. So let's say this. N minus 1 factorial is definitely greater than or equal to 2 to the n. For like, what value of n does that happen? At 1, no. At 2, no. At 3, you get 2 factorial versus 8, nope. At 4, I don't know. Like, what's 6? So 5 at 120 versus 2 to the 6. 2 to the 5th is 32, so 2 to the 6th is bigger, 64. So, okay, so I'm going to say for n greater than or equal to 6. Just has to be eventually, which means that 1 over n minus 1 factorial is less than or equal to 1 over 2 to the n. And then if this is true, so now it's a, what, direct comparison? Yeah, so let's go back and say that our series that we're dealing with is actually this. 1 over quantity n minus 1 factorial. Okay, so since 1 over, I'm going to do a little more describing here because my work is worse. For n greater than or equal to 6, and what? The sum of 1 over 2 to the n converges because it's geometric. Woo. R equals 1/2, which is less than 1. Okay, so since that's true, we know that the natural log of 3 times 1 over n minus 1 factorial converges by direct comparison. So I don't know. I don't like using direct comparison, but when you need it, you need it. All right, so I don't know. That's like a weird one. Factorials grow really, really fast, so it's really easy to compare them to things, but like if you have to come up with the n where it happens, sometimes you just want to grab a calculator and have it do it. All right, so that was a lot of practice problems. So I hope you found that helpful. I'm going to end the video here, come back with, I guess, some new notes. So I will see you there.